So students, welcome back to this channel where we try to make math a bit more fun. We were on our ITF series, inverse trigonometric functions, and this is another third video of that. In the previous two videos, I have already explained what ITF functions are and how they work for cos inverse function, sin inverse function, both. And today we are going to be diving deep into this tan inverse function. So you have this tan function which takes theta as its input. Theta is an angle of a right angle triangle. This tan function on this angle theta gives us the ratio between height and the base from the perspective of this. So tan theta here would be the ratio of AB and BC. Now tan inverse of that, which means that there is a function that takes this input value and gives us the angle for which tan theta would be equal to that value. Let's say this value is 6, so tan inverse of x or tan inverse of AB over BC is gonna be theta. Okay, but again, like what I have told you guys in sin and cos videos as well, that this is not completely true. Why? Because trigonometric functions are cyclic functions, which means their values keeps on repeating after a certain time. So let's say we have been asked to evaluate tan of pi over 3. This would be root 3. Writing this equation like this, there's nothing wrong with that, but saying that tan inverse of root 3 is going to be pi over 3. It's going to be just pi over 3. There is not going to be any other possibility for which tan inverse of 3 is root 3 is pi over 3. That would be not correct, because after a certain interval, trigonometric values keeps on showing up again and again. So for root 3, this function tan inverse would definitely give us pi over 3, but this is not the only possible answer, only possible value of this. Pi over 3 is not the only possible value of tan inverse root 3. There are also a lot of different values of theta for which tan inverse is going to be, for which tan theta is going to be root 3. Another example of which can be let's say tan 240 degrees, or it's gonna be tan 4 pi over 3. Tan pi over 3 is root 3 as well, but tan 4 by 3, the value of this is root 3 as well. So saying that root pi over 3 is going to be the only solution for tan inverse root 3 is going to be incorrect. There are countless, numerous possible values of tan inverse root 3, and we have to write them all in a general format. So how does the general formula of tan inverse x looks like? It looks like n pi plus theta, where n belongs to the set of integers. Okay. here you can put different values of L and find out different possible different values of this tan inverse function. Let's say for this area, root 3. One first time this is gonna show up the value of tan. So root 3 is gonna show up for tan function is pi over 3. So we can write like that. Tan inverse of root 3 is going to be n pi plus pi over 3 for different values of x. Let's say n is 1. So tan inverse of 3 would become pi plus pi over 3. This is 4 pi over 3. If n equals to 2, this would become 2 pi plus pi over 3. This is 7 pi over 3, and so on. For all of these values, the output of tan theta is going to be root 3. Okay, this is the general value of tan inverse of x. I would definitely recommend you noting this part down. Now, what is gonna be the primary value of tan inverse function? Like I told you in the previous videos about sin and cos functions, the primary value is always has to be in a range inside of which all the possible values of the original trigonometric function are covered, and if that range is in the positive side, then that is a good thing. So, and how are we gonna find out about that? That has to be with the help of the graph of the tan function, tan theta function looks like this. It was like the x-axis represents the value of theta, and the y-axis represents the value of tan. Okay, and this over here is minus pi over 2, and this value of x over here is pi over 2. Now you can say that you can definitely clearly see that all the possible values for tan theta is covered inside of this range from minus pi over 2 to positive pi over 2. What is the lowest possible value of tan theta? 0. When value of theta is 0, tan theta is 0, because say we have a triangle here, at a triangle, this angle is theta, ABC. Tan theta is going to be AB over BC. Now, what if this angle is 0? If this angle is 0, that means the triangle is going to look like this way. The base and the hypotenuse are going to be the same side of the triangle. They are going to have the same length, and the length of the height is going to be 0, because only that way this angle will get to become 0. So in that case, tan theta would be 0 over BC or 0. Okay? This is the lowest possible value of tan theta, because we are not taking modulus values. For sine values, this is the lowest possible value. Actually, I think that was wrong. For sine values, the lowest possible value will be minus infinity. Why does that happen? Actually, you know what? I'm gonna cover that later in the video. But for this particular video, let's keep in mind that the value of tan theta keeps roaming around from negative infinity to positive infinity. For minus 5 over 2, tan theta is negative infinity, and for positive pi over 2, and it is positive infinity. So this range has all the potential values of tan theta covered inside of it. And this, even though this range is not only positive, you know that if you start, I mean, you can definitely start from here and say that all the values have been covered inside of this range from 0 to pi, which will be here. This value is pi, but we want to get inside of a range that is the closest to the origin point. If it's totally positive, then that is a good thing. Like what the situation was with cost function. What was the graphical cost function look like? It looks something like this. On both sides, values of all the possible values of cost function have been covered. But this side, like going either way is gonna be the same. But since this side is positive, then I'll go with there. But from for this particular tan theta, we will have to go both sides. We have to like move forward towards both sides to get inside of the range. So that is why all that all this happening was just to give one thing, that the primary value, I would definitely recommend you to note this part down. Primary value of tan inverse x is between minus pi over 2 and plus pi over 2. But we will have to make sure of one thing, that the value of tan inverse of x cannot be this pi over 2 or minus pi over 2 and plus positive pi over 2 themselves, because minus pi over 2 is tan minus pi over 2 is minus infinity, and tan pi over 2 is plus infinity, both of which are undefined numbers. Of course, if a number is undefined, so we definitely cannot actually reach to that point. You can see that from the graph as well. This is pi over 2, positive pi over 2, and this is negative pi over 2. This on the right side, on the positive side of the x-axis, the y value of tan theta shoots up to infinity. On the left side, it shoots up to negative. It shoots down to actually negative infinity. So definitely you can see that both of these values are undefined. So tan inverse of x, first of all, the value of x can be infinity, and secondly, output of tan inverse of x can never be infinity. So the range of this function, first of all, let's do the domain. Domain is gonna belong to a set that starts from negative infinity and ends in negative infinity actually, yeah, and ends in positive infinity. It cannot touch negative infinity in the third, because infinity is again is totally on the words defined, so you cannot reach there. You can never approach that there. And range, which is the possible domain, is the possible input values, and range is the possible output values. Sets of that actually. The range is going to belong to a set of minus pi over 2 to plus pi over 2. And again, we are using cross brackets there, because this shows that we will only be able to approach this. Negative infinity, positive infinity, negative pi over 2, positive pi over 2, but we cannot never actually reach this. Okay. So this was it for our 10 inverse function. In the next video, we will talk about cos inverse function. If you think that you have any doubts regarding anything I have taught in this video, definitely you can let me know about the conversation. I will try to resolve your doubts. Until the next one, keep learning.